Hey, good morning. Today we're going to do a mid-chapter review here. A lot of you are struggling with some of these early concepts, and here's a quick reteaching on about 4 or 5 of the first targets. Okay, for the first target, you need to estimate the sum or difference. The sum means adding, the difference means subtracting. This is video 5.1a if you want to refer and get more instructions. So we look at a fraction, and when we're looking at fractions, when we estimate, we have to estimate to either the 0, to the half fraction, or to the whole fraction. Which is it closer to, a 0, a half, or a whole? So 4/5 is almost a whole, so we're going to call that 1. We're going to add to that 1/16. 1/16 is barely anything. If you think of a pizza with 16 pieces and you only have 1, that's nothing. So we're just going to call that 0. So my estimate for this is 1 plus 0, or 1. And I'm just going to put my answer up in the box there, so it's easy for you to see it and for me to see it when I come around to check your work. This next one, we have 4 7/8. So we know we have 4 whole pizzas, but the question is, on a mixed number, we instead of rounding to the closest 0, half, or whole, we're just trying to figure out, is there enough there to call it the next number? So we have 4 wholes for sure. Is there enough there to call it 5? Well, we have 4 whole pizzas and 7 pieces out of 8. So yeah, that's enough there. We're going to call that 5. It's more than a half. We're going to subtract 2 1/10 here. So we have 2 whole pizzas for sure, and we have 1/10 of another pizza. Is 1 piece out of 10 enough to bump this from 2 to 3 pizzas? No, it's not enough to round up. So we're just going to call it 5 minus 2. And of course that equals 3. And we'll put our answer up in the circle. All right, that is all 5.1a. All right, now 5.1b is very similar, except for we're going to estimate the product or the quotient. So the product is multiplying and the quotient is division. So let's take a look at this one. We have 2 4/5. Now the same rules are going to apply. 2 4/5. Is there enough to call that 3? Well, we've got more than half. We have 4 pieces out of 5, so we're going to call that 3. This next one is 5 5/8. So we have to multiply that times 5 5/8. Well, 5 4/8 would be half. We have 1 more piece than half. So yeah, we're going to call this 6. And so our estimate is 3 times 6, or 18. And again, we'll put 18 up in the circle. All right, now we have a division problem. So we have 31 and we have a half. Well, this is right dead in the middle, and I'm not sure what to do. Let's do the other side first. We have divided by 3 7/8. Well, this is certainly more than 3, and 7/8 is a lot, so we're going to call this 4. And now when I think back upon this, 31, I can't divide 31 by 4, but I can divide 32, and remember it's right there at the half point. And so we're going to use 32 here. And generally, when I hit the half point like that, if it's something and a half, I generally round up. That's a pretty good idea, but you can look at it and decide what's going to work best. Because remember, it's just an estimate. That's a close approximation. So we have 32 divided by 4, which is 8, and I'll put that in the circle up there. All right, now this next one is just a target that's been killing kids, and that's expressing mixed numbers, or improper fractions to mixed numbers and mixed numbers to improper fractions. So let's take a look here. The first part of it's pretty easy. Express mixed numbers as improper fractions. So I'm going to go up here where you can see, and I'm going to write this mixed number 3 1/3. Now the way you make that into a improper fraction is you multiply down and then you add the top. So I always make that little drawing there. I guess I got to slide that over just a touch so you can see it. There's the adding the top. So 3 times 3 is 9, plus 1 gives me 10/3. Now if you take 10 and divide it by 3, you will get 3 wholes and 1/3 left over. So I know I have my answer right. Well, this little process right here is crucial to be able to multiply and divide fractions. So that's why I made it its own target. This is 5.2c. I would watch and practice this one. This is what most kids are struggling with. So 1 1/2. 1 times 2 is 2. If I add in the top, I have a total of 3 halves. There's my answer there. This next one I've got to do a little bit more work, a little bit bigger numbers. 7 times 3 is 21, and then I have to add the 2 pieces on top, so I get 23 thirds. And if I were to take 23 and divide it by 3, because that's what that means, I would get 7 wholes and 2 parts left over. All right? All right, now we're on to the trickier of the two, and this is where we have to express an improper fraction as a mixed number. So now we have 14 divided by 5. And there's a couple of ways we can do this. I'm just going to grab a little piece of scratch paper here. So 14 divided by 5, what that really means is 14 divided by 5. That fraction bar means division. So one simple way to do it without dividing is to say that, well, here's my 14/5. How many wholes are in there? Well, if I subtract 1 whole pizza, there was 5 pieces in it, I could do that. There's my whole I've subtracted. Now 14 minus 5 here would leave 9 pieces on top left over. That's still an improper fraction. So I'm going to take another whole out. All right, here's my second whole. So I take 9 minus 5, and I have 4/5 left. Now, that is a regular fraction. That numerator is smaller. Sorry about that. That numerator is smaller than the denominator. So you'll see that I'm going to color these in to show that these were wholes, these 5/5. You'll see that I have 2 whole pizzas I took out of there, and I have the 4/5 left over. Now, this is the way that you can do these problems without having to necessarily divide. Really, division is repeated subtraction. That's what we did. We just subtracted out wholes. Here's the other way to do it. If you are good at division, you can take 14/5, and you can take, that's 14 divided by 5. Now, Miss Wooten always says, here's an ice cream cone, and you put the ice cream in the fridge, and the cone stays outside the fridge. So if that helps, we'll thank the Wooten Tootin' Cowboy for that one. But then we just do division. We ask the questions. Does 5 go into 1? No, it doesn't. Does 5 go into 14? Yes, it goes in there 2 times. I like to put a little multiplication symbol there. So 2 times 5 is 10. When we subtract that out, we have 4 left over. I can't go any farther. In elementary school, you would call this the remainder of 4. Well, the remainder becomes the numerator. So here's our answer. So we have 2 wholes, and our remainder is how many parts out of 5 we have. So there is my 2 4/5. There's a quick tutorial on improper fractions and division. All right, so this one, as we just did, it's 2 4/5. Now this one here, 18/4, I'll do the same thing. I'm going to subtract it out. So I have 18/4. I know that there are 4 holes in a whole pizza in this case, so I'm going to subtract out 4/4, and I'm just going to put a little 18 minus 4. That leaves me 14 left. So I'm going to go ahead and take out another whole one. 14 minus these 4, that's going to leave me 10 left. I can still take it out. I'm going to take out another 4. Now 10 minus 4, that leaves me 6. I can still take out another 4. I'm running out of room here. I've got to slide that over a little bit so you can see. And you'll see that I've taken 4, 8, 12, 16. So I only have 2 left over. So I took 4 wholes out, and I still have 2 parts out of 4 left over. So my total here is 4 2/4. Now let me just check to see if it works. 4 times 4 is 16, plus 2 would be 18/4. But we can't leave 2/4 sitting there like that. We have to say that we can divide that by 2 and divide this by 2, and we get 1/2. So our actual answer then is 4 1/2. So that was kind of a tricky one there, but it is very testable. That's a 6th grade question right there. All right, so let's move on now, and now we have to multiply fractions. I think this is the easiest target that you're going to have on the entire test, so let's just bomb through this. Multiplying fractions is simple. You can just multiply straight across and then reduce. You can also cross reduce, and I'll show you that in the next one. So in this case here, I'm just going to multiply straight across. 1 times 3 is 3, and 2 times 4 is 8. That's it. No common denominator.
Please report to the office. Carla Edmonds, Karen Scott, Monica Bellows, Chastity Carlton.
Sorry about that teacher announcement. So we have 3/8 there. Now on this next problem, I'm going to do it two ways. I'm going to rewrite this down here. We have 7/8 times 4/5. Now what you can do is you can just multiply straight across when you have two fractions. So you would say 7 times 4 equals 28, and 8 times 5 equals 40. Now you can reduce from there. I know that I can divide both of those by 2. So divided by 2, divided by 2, it looks like we've got 14/20. Well, it looks like I can still divide by 2 again. So I'm going to divide by 2, divide by 2, and it looks like we have 7/10 remaining. Okay? Well, you can do that a different way as well. You can cross-reduce. So we look at these two numbers here diagonally. Can I do anything with them? Do they share any common factors? And they don't. However, if you look this way, these numbers do share a common factor, and that is 4. So I'm going to divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. So now I've rewritten this problem, and it's going to make it a lot simpler. I still have to multiply straight across. 7 times 1 is 7. 2 times 5 is 10. And there's my answer when you cross-reduce. So if you understand the cross-reducing, that's fine. You'll notice that we divided by 2 and we divided by 2. Anytime you divide by 2 twice, you're really dividing by 4. And that's just what we divided by up here. Always check your answer to make sure that it is in simplest form. And 3/8 and 7/10 are in simplest form. All right, so now we got to put all of these things together in order to solve these next few problems. And I'm going to slide this down a little bit. I'm going to do 11 and 13 first, and then I'll move the paper over. So now we have to take this mixed number and we have to flip it into an improper fraction before we can multiply it. So remember, we multiply down and then we add the top. So 2 times 2 is 4 plus 1. This gives me a new problem called 5/2. And we're going to take that times 3. Now, any number like 3 or 4 or 100 or even a gajillion, if that was a real number, you can just put it over the top of 1 and make a fraction. I like to do that. It makes multiplying the fractions easier because now I can just multiply straight across. 5 times 3 is 15. 2 times 1 is 2. So I have 15/2. So now I have to simplify that. Well, I'm going to do it this way today. I'm going to do 15 divided by 2. Does 2 go into 10 or into 1? No, it doesn't. Does 2 go into 15? It does go into 15 7 times. That's 14. And then I'm going to subtract out, and I've got 1 left over. So you'll see that I have 7 wholes, 7, and I have 1 part. That remainder is the number of, in your numerator, the number of parts you have out of 2. And your divisor up here, that is your denominator. So I have 7 parts and 1/2, or 7 and 1/2. So I'm going to stick that up in here. And let's just see if it makes sense. I've got 3 times 2.5. Well, that's 3 times 2 would be 6, and then I have the 3/2. So that looks like 7.5, and that answer makes sense. So now I'm going to take a little more complicated problem. We have 2 problems that we have to switch here into improper fractions. So we have 2 1/3 times 1 1/7. Why don't you just take a second and see if you can make those into improper fractions first. Okay, well, 2 times 3 is 6, and if I add that top, I have 7/3. Okay, now 1 times 7 is 7. If I add the top, I'm going to have times 8/7. Now, I'm going to look diagonally here, and you see those 2 7s? I can divide those both by 7. 7 divided by 7 is 1. 7 divided by 7 is 1, and I just made my life a lot easier. I still have to multiply across. 1 times 8. So 1 times 8 is 8. 3 times 1 is 3. So we have 8/3. I'll do this the other way. Let's subtract out. So I know that there are 3/3 in a whole. So if I take one whole out, 8 minus 3, I'm going to have 5 left over. I can take another one out, 3/3. So now I've taken 6 out, and so 8 minus 6 leaves me 2/3 left over, and then I'll color these in lightly. So those show my 2 wholes. So I have 2 and 2/3. Let me just verify my answer. 2 times 3 is 6, plus 2 is 8/3. So yes, my answer here is 8. Ooh, I wrote my answer wrong. It's 8 and 2/3. I need a sharper pen, don't I? Okay, well, let's try these other two. And I'm just going to pause for a moment on that first problem and see if you can turn those into mixed numbers and try it. Okay, well, I have 2 times 2. This is 4 plus this top is 5/2 again. Seems like we've done that one before. I tried to keep these simple so you could be successful. And then 1 times 10 is 10. We add that top, we have 11/10. Okay, well, I've got a 5 and a 10 here. So I'm, on this one, I won't cross reduce. I could, but I'm just going to show you it works out the same. So just multiply across. 5 times 11, that gives me 55. And then 2 times 10 is 20. So I have 55/20. And let's subtract this one out here. So I know that there are 20 pieces in a whole. So I'm going to take out one group of 20. That's going to leave me 35 left. I can still take some more. Take out another group of 20 there. So here are my wholes. So now I've taken out 40, and I have 15/20 left. 15/20. So I've got these 2 wholes I took out. So there's 2 and 15/20. 15/20 I can reduce. I can divide these both by 5. And I can get that to 3/4. So my answer in simplest terms is those 2 wholes and 3 out of 4. 2 and 3/4. And let's see if this makes sense. We've got 2 times 1. My estimate is about, well, if I round this would be 3. 3 times 1. Yeah, my answer is about 3. It's 2 and 3/4. So 2 and 3/4. Okay, and we've got one more here. We've got 4.5 times 3/9. Okay, so let's make these. Why don't you go ahead and try making them into proper fractions? All right, so I did 4 times 2 plus that 1 on top. 4 times 2 is 8 plus 1 gives me 9/2. And let's see, I've got 1 times 9 is 9 plus the 3 on top. That gives me 12/9. Now, I'm just sitting there looking at those 9s going, I can divide this guy by this guy and call that 1 and 1. That made life a lot simpler. But I'm looking over this way, and I can divide these guys too. I can divide by 2 here and call that 1, 2. There's 1, 2, and 2, and there's 6 in 12. So look how simple my problem became. I've got 1 times 6, which is 6, and I've got 1 times 1. I've got 6/1. Now keep in mind, that means 6 divided by 1. 6 divided by 1 is 6. There's your answer right there. Let's just do a check and see if it makes sense here. Well, I have 4 and 1/2, so I'm going to call that 5. And that's 5 times a little bit more than 1. Yeah, that makes sense. That's about 6. My estimate looks close. All right. Thank you for listening. I hope this helps. Have a great evening.